Okay, so I've already told pretty much the majority of you about my dislike for FOIL. In this example, you won't see it as much, but in other examples you will. Because FOIL I don't like because you can only use it when you have a binomial times a binomial, right? So what I call is I say we're going to use the distributive property, which is where we're going to distribute each term in the first set of parentheses to every term in the second set of parentheses. So you might say, but there's 3 factors. I get that. Each of these are factors. X plus 1, x plus 2, x plus 3. We just went through, not just went through, but we had a unit on factoring. Well, this, we are going to undo the factoring and we're going to multiply it out to see what the expression is in standard form. So to multiply, we need to just kind of ignore one of your parentheses. You can ignore any one, it doesn't matter. We know from chapter 1 that we can multiply in any order that we wish. Just look at 2, so I'm going to look at the first 2 here and multiply those. FOIL those if that's the word you want to use. But I'm going to distribute each term in the first set of parentheses to every term in the second. So x times x gives us x squared, and then plus x times 2 gives us 2x, and then plus 1 times x gives us 1x, and then plus 1 times 2 gives us 2. Okay, now I can simplify this and I'll have x squared plus 3x plus 2, but that's not my answer. That's what those 2 multiply to. So I also have to take this and multiply it by x plus 3. Now here again, why I don't like FOIL. Because there's no, yes you have first terms, yes you have outside terms, but where's the inside terms? Where's the last terms? We're missing some terms here when we have a 3-term polynomial. So using the method I used here, we're going to multiply every term in the first set of parentheses with every term in the second. So we're going to do x squared times x. Remember our rules of exponents. When you multiply, you add your exponent, so x squared times x to the first is x to the third, plus x squared times 3, x squared times 3, is 3x squared, and then we have to distribute this term to both the terms in the other set of parentheses, so we're going to do 3x times x. Again, when you multiply 2 variables, add your exponent, so that's 3x squared, and then plus 3x times 3, well that's 9x, and then we have this last term that we need to multiply to both terms in the other set of parentheses as well. So we're going to have plus 2 times x, and then plus 2 times 3. Well, 2 times x is 2x, 2 times 3 is 6. And then it's just a matter of combining your like terms. So we'll do x cubed plus 6x squared plus 11x plus 6. Some of you might say, well, why aren't you adding your exponents here? Remember, you only add your exponents or adjust your exponents when you're multiplying or dividing. Here we're just adding. So when you add like terms, you just add the coefficient and carry the exponent with its variable. So the final answer here in standard form, because in standard form the polynomial has to be written in descending order. So there it is for you. All of the exponents are in descending order. Now this next example, this example 2, I am going to get it started for you, but I want you to actually finish it, and that's one of the things I'm going to check when I grade your notes or your homework in class tomorrow or the next day, whenever you're doing this. So for this, same thing, we need to multiply. So you can ignore the third, or I said you can multiply in any order that you wish. Let's just pick these first 2, and let's FOIL or use the distributive property like I've already suggested. So doing that, we'll have x times x, so there's our x squared, x times 2, there's our 2x, 1 times x, there's 1x, and 1 times 2, there's 2. Some of you might say, why'd you do that so quickly? Well, we just did it in the example above, the exact same 2 factors we multiplied. And we, once again, got x squared plus 3x plus 2, you're supposed to. And then we have to take this times x plus 1. So this will be different from the previous example. So I want you to go ahead and try that out. And so why don't you pause the video, because here is your answer. Actually, no, I'll give you the answer in class. I'm not going to put the answer up there. We'll do the answer in class.